Paulina, and we have a special guest today.
Hi guys, thanks for having me.
Do you want to tell us a little bit about who you are, what you're doing?
Sure. Yeah. So my name is Birol. I live in Germany, and I run a company for incident response. a SaaS company. We help companies respond to incidents faster. And I've been in that field for maybe a decade. Yeah, that's why. Yeah.
So how do you end up in a decade in incident response, right? That would be the first question. Like, did you work at a big company, like a bank, or smaller, or like how do you end up in that like box of the security field?
It started actually sooner than my professional career. So I was working as a working student and doing my master's thesis for this software company. It was a product company selling software to like legal firms in North America. And they had this requirement where they wanted to have 24/7 support, and their clients were usually very highly paid lawyers who needed immediate support if there is an incident, right? If the software doesn't work. And my task, and this was 2010, I believe, so there weren't APIs for everything. There was no Twilio. There was no things were very basic, and just a basic task of getting immediate human attention. Like, let's say you want to send an SMS if there is a ticket, or if there is Nagios tells you something is not working.
Nagios,
yeah. That was like that wasn't very trivial back then. So this is how it started, right? And then I finished that and I started working in companies, and this problem of having 24/7 teams was also something that I experienced in my last role at Rewe Digital, one of the largest grocery retailers in Europe. We're building this online grocery store, and we had 24/7 services all over the place. And so this is how more or less I always had touch points with incident response. And and back in 2019, we launched the current version of iAlert, and that's how I came into that field. Yeah.
Nice. And I think it's starting to grow as well now. I think with the new directive we're getting in Europe with NIS2 and DORA, you have to have an incident response.
Yeah, absolutely. Right? So these are two new regulations that that require require companies to meet certain standards, at least companies that meet certain criteria. So I think, but even without the regulation, if you're running business critical services to your company, you want to have a way to remediate incidents very quickly, because it's business impacting, right?
Do you see the difference since the regulations come into life, that there is a change on the market? More people are interested in it, or not really?
Yes, so far we have been serving companies who mostly very mature in their in their tech capabilities, right? So who inherently have this need to bring immediate human attention. The regulations, I wouldn't say they changed the market dynamics, at least for us. They added additional documentation requirements. But most of our companies, most of our customers, we serve customers, from commerce to finance to logistics, insurance. They have this inherent need that they want to respond to incidents fast. So I would say it changed the bureaucracy, but not the market dynamics. At least this is our experience. Yeah.
I mean, it's a lot of companies talking about like shift left, right? We're taking security and moving that to the start of developer things. But one of the keys when we talk about incident response is the way that we learn from incident and like make our products better. And sometimes it feels like incident plan is almost like a production scanner. You just need to have it, you add it in the end, and you don't give it that kind of love and work that it needs, because a good working incident response plan like finds your troubles and feeds them back to organization, and then improves like so you have a systematic workflow and like improving your organization. How many of your clients have that like really built out and work in that sense, like in the cycle of just improving the organization with incident, and how many is like, oh, we need to have it, just add it in the end, and like, okay, it's a check in the box now for security or compliance?
I think it varies from category to category. So to give you an example, one of our customer segments are managed service providers, right?
Yeah.
They operate infrastructure on behalf of their customers.
Yeah.
And I would say for some of them, their ability to use incidents as an opportunity for self-improvement is probably limited, because they don't have that, they don't have the level of control that they would need in order to, maybe introduce radical changes. So those companies, for them, incident response is more reactive. They want to, they have contractual agreements with their customers that they need to respond within a set period of time. But then again, if we talk about the mature companies, like mature in the sense regarding their tech competency, their DevOps maturity, right? Then those companies, for example, yes, they use incidents as an opportunity to learn, right? So they have practices like they conduct post-mortems, and then they try to learn from an incident and implement measures to prevent that same category of incident happening again, right? So I think and so far, I'm sure there are companies for whose it's just a checkbox, but most of our customers, because there are cheaper solutions, if you just want to, get awareness, receive an SMS, receive a phone call, there are cheaper solutions out there that you can use if it's just a checkbox requirement for you. So I think I hope that answers the question somewhat. Yeah.
Cool. I have a lot of questions. Let us start from like the beginning. Let's dive deep into like how AI and tools can help us in the incident response. And the first thing is like, it's when an alert becomes incident, like you get an alert, how would you know that this alert is an incident? Like how will you see the level of the incident, like, and help with different tools to detect what you should do. Like, for example, I'm using a SIEM now. I get an alert. I can run that into my SIEM to get correlation rules, like alerts that trigger close to it, and see like, is this something new that's coming? Is this something that's widespread, or where can I see it? But when you're working with alerts and incidents, like, where do you see that AI can help us here to make better judgment of the alert severity?
Yeah. So I think like just maybe to answer the question, first, unrelated to AI, right? So how can you use an incident response platform to make better judgments, to reduce alert fatigue? Because after all, an incident response platform doesn't have a value in its own, right? You wouldn't just have an incident, like you talked about SIEM, for example.
Yeah,
right?
exactly.
SIEM has a SIEM system has its value, right? In a different way. An incident response platform is the main goal of an incident response platform is to reduce MTTR, reduce the time between a problem happens, a human is working on it, and you mobilize an incident response team. And at the end, you want to like mitigate incidents as fast as possible, right?
Yeah.
So it starts with, for us, for example, we have 150 plus integrations. So that means we integrate with every tool out there, and we have a fairly good understanding of, how should alerts look like across, multiple, very diverse tools, right? And then, even without AI, how can you solve problems such as alert fatigue? And there are like simple solutions that sometimes help. Like you can start with time-based alert grouping. You can start to group if the alert itself contains information where it already designates that okay, these two alerts might be related. So those are the easy like the easy cases, right? And then you can go as far as like, for example, something we used even before AI is intelligent alert grouping, where AI was still involved, but not in the same way that today when people talk about AI, they think about agents, they think about LLMs, right? But the way we for example use AI models before was to understand the semantics of alerts. And then maybe even if you have two different alerts that are completely different on a textual level, but they refer to the same problem. So just to give you an example, when let's say a hard drive is full, there are multiple ways to express this, and maybe you have like tools on an application level that tells you the same problem. Then you have tools on an infrastructure level that tells you that okay, you have this hard drive problem. You can use intelligent alert grouping where we vectorize alerts and try to understand the semantic similarity between those textual things, and then just intelligently group them and just have a time window so you wouldn't so the risk of grouping two alerts that are not related to each other gets lower, right? Yeah. So those are the basic things. Then your actual question is, how does AI help along the incident life cycle, right? Basically, that's
yeah, exactly. I mean, we can start with alert, but it's funny that you said like in August in the beginning, because I started also looking at like in August was the first thing you had alert. You had like, and hard disk would be like OK, warning, critical. Like you have 3 levels, right? That was the thing you had on August. But in reality, it's the hard disk is much more fine curved, right? It's more like how many percentage is left of your hard drive. And August could actually send on a critical when you still have many gigs of data still there, right? Running. Yeah. We all see that. So it's interesting to see like the more system you have, the more data you have, and the more hard it becomes to see like this alert I'm getting, is this really meaningful for an incident, or is it just like a regular alert that I can ignore? Because we really want to limit our alerts and human interaction with it, right?
Yeah, absolutely. And I think this is probably like it's not a tool problem in the it's not a piece of technology should solve the problem. It should start with the human that designs the alerts, right? First, you want to make sure that alerts are actionable. They need if they need immediate attention, only then you should alert. And if it can be automated, like for example, having an alert for hard disk drive or CPU, like if your CPU hits 80%, that's not a problem per se, right? That means you did something right when you were doing capacity planning, right? Yeah. So your system doesn't have to run at 10% all the time. So I think it starts with, and of course, and this is something that we always recommend to solve at the source, right? So because this is the place where you have most of the information, where you can design the alerts and set conditions. Not sure if it's possible in Argus, but many modern observability tools have this way where you can say, okay, if I have a certain condition for a set period of time, then maybe that's a situation where I need to have a human look at it, right? If whatever the human would do can be automated, probably maybe you should automate that as well. Like if it's really that simple as if this happens, then do this, right? Yeah. So yeah, it starts with the basic principles of designing alerts that are actionable and usually this is a problem that is solved automatically when the same person who runs the system is also the person who develops the system is also the person who is on call, because then you have this very short cycle of if I have bad alerts, it affects me. Then I have
speeds up the process, right? To wake up in the middle of the night, you need to fix this. Yeah, but that's true. I think we've all seen companies you go to, they had a Slack channel and alert is just hammering in all the time, right? And nobody really cares about that alert, right? And you ask this alert is coming in here. Do you know what it is? Yeah, it's been going on for a long time. We just ignore it, right? Yeah. This is not really how you should do, right?
Yeah, it's a cognitive load, I think sometimes, like we have limited cognitive load, which we can use during a day, and you have sometimes hundreds or thousands of the notifications from people, from other teams, from system, the alerts. So we at some point start to ignore it because it's not important unless people start screaming. Then if it's really important, the human will, you're gonna get not only machines, you're also gonna get humans coming to you.
Yeah, that's the problem. Yeah, people coming.
But once humans are involved, then you lose time, right? So because you lost time, because like this is a situation where there was an alert, you ignored it because you assumed, okay, this is the same alert that has been going for quite a while. Then maybe you have a customer screaming, right?
Yeah,
this is a problem. Can you please take a look, have a look at it? So this is like, yeah, that's time lost, valuable time that you've lost, and of course you want to avoid that.
Yeah, but that's going to be a problem for the incident. The more alerts you have to pick, right? Is this incident or not? Like, how would you really know and which one you should go on, right? The incident is something that interrupts the business or costing money or like infecting the business that you have, right? And it's hard to tell sometimes. Is this a real alert or is it not, right? As I said, like CPU 80 can be fine, right? Shouldn't infect the business. But if it goes up to 100 and stays 100 for a long time, you might get into trouble. Maybe you should check like how fast this page can load instead, right? Something else, right? To get the perfect matching for this. But
another thing which is coming with it is also, okay, what confidence do we have? Because if we're gonna, if we count on AI to being able to tell us, okay, is it the incident or not? How much do we trust it also?
Yeah.
And how can we ensure that the trust is high for us to being able to count on
it? Yeah, that's a fair question. And like so far, I haven't talked about how AI can help with that, right? But I can give you like, first of all, there are many things outside AI that you can do to reduce the problem of alert fatigue. Like one would be, for example, to have, that's why our category exists, right? You have dedicated incident response platforms that serve as the central dispatcher, that have a broader view of your entire infrastructure health across multiple monitoring tools. So you might be using a different tool for application performance monitoring than you use for network monitoring, for example.
Yeah.
And having an incident response solution that where the only reason for being is solving that problem, where you have a lot of things that you can configure. Some of the things we talked about, like intelligent alert grouping, time-based alert grouping, and then refining your own rules, right? But you can still end up with because sometimes you have problems that will lead into multiple alerts, but they are still related to the same root cause, and they are semantically completely different because you have a central component that is affected, and this leads other downstream services that are also affected. So intelligent alert grouping wouldn't help here because they're like the alerts itself, they are completely different, but they're related to the same root cause, right? Yeah. And one way how we use and I wouldn't even say it's like AI driven, but one way is, again, if you have lots of data, we try to build a topology of the services that our customer is using, right?
Oh, that's nice.
And yeah, and of course you can have traces, right? But only like not many companies have traces end to end, like implemented traces across the entire stack, right? Entire stack. Yeah. So one approach where another approach to get the data is adopt techniques such as eBPF based tracing, where you just install an eBPF collector, and then we extract the useful information and build a topology, right? Or maybe you have a service directory where there is already topology information, but and that's one, like a very effective way to understand relationships between services, and then map those relationships to alerts that happen in a very short period amount of time, and then understand, okay, this alert was caused because this other dependency has an issue, so I can group them, right? And then the other part of your question, what's an alert, what's an incident? We don't, we don't try to distinguish between those two in the very first place. So for us, an alert is something that needs immediate human attention. It might not have the business impact yet, because there are alerts that still require immediate attention. Like, for example, the hard drive of your database is like 95%, right? Yeah. So no business impact. But if you wait for maybe 2 hours more, then you will have real business impact if it's a central database, right? So that would be an alert for us, and you can like perfectly, you get page and then you solve the problem, no business impact, right? Yeah. But what would be an incident is if there's already business impact, or maybe you need we use incident as coordination anchors when you want to mobilize a bigger response team, and you want to have maybe all hands on deck, and you want to have a space where you can collaborate effectively across multiple departments in engineering, and then you can mitigate the incident. So to answer the question, we don't try to we don't try to distinguish between those two, what's an alert, what's an incident, but instead we start with limit yourself to things that need immediate human attention, that are actionable. If it's just information, it can be a low priority alert. And a low priority alert doesn't, by design, wouldn't page you in the middle of the night, for example. Yeah. So it can wait for the next business day.
I agree to that. I will say, we talked about Nagios. It's funny now. I don't know if anybody's still using it. Maybe in different things. But the warnings are the most one you should look for in Nagios or in Zinka, because those are the ones that tell you, things are about to go shit, right? Yeah. You should check this now before they go critical, because they will go critical at some point, right?
If you ignore them, right?
Yeah. If you ignore them.
Yeah, so it's still talking about shifting left pretty much, yeah?
In the alerts, we need to shift left, right? Because you need to get the better alerts you have, the better judgment you can take, right? Of course. And it's all going back to it. Sometimes you chunk in alerting tools, and then you get a lot of alerts, but then you need other tools to go over them. But shift left is the way to go here. But let's move to the next path, or the steps of incident. Incidents happen, right? But what help can I get now? Can we use external parties to get information about the incident? Can I have access to emergency power? What should I do, and what help can I get from LLM or platforms when I'm in the incident now, and I'm the incident response leader right now?
Again, this question can be answered in two parts. One is if you take AI. If you act as if AI doesn't exist yet, and first of all, your page in the middle of the night, and your first job is to to create situational awareness. Is this something that has business impact already? Do I need to update my customers, right? Maybe I have a status page, or I want to it doesn't have to be customers. It can also be internal stakeholders that are also affected by this incident, and they have their own business response to technical incidents, right? And then the second question is this something I can fix on my own? Let's say I'm an on-call responder, I'm the first responder, it's 3 a.m. I look at the alert, and then hopefully the alert, and this is what we try to do, we provide as much information as possible. So including when it's an alert that comes from a SIEM, for example, there will be a backlink that points to the to the dashboard or whatever source, so you can create situational awareness very quickly, and we receive ongoing updates, right? And when you have when you know whether it's something you can fix on your own, maybe you should do that immediately, and maybe you can just update if it has business impact. You want to update your status page, your customers, and we make that very easy. You just ask about how can AI help. That's one of our first use cases. How we used Gen AI was to draft incident updates, right? Yeah. Because when you're doing incident response and you are in firefighting mode, the last thing you want to worry about is, how can I frame this in a professional manner? That is that is in line with how we want to communicate with our customers.
Yeah.
And so we have this, in the platform, it's integrated where you can just type in a few keywords. It can be as things like payment API is broken or nothing works, right? But then it will just create a very nice message. So you have that out of the way. It saves you maybe a few minutes. If you need more support, you wanna make it very easy to mobilize additional responders without, looking into a sheet and saying, okay, today is Tuesday, it's 3 a.m. I need someone from the database team, and it's John who happens to be on call. You don't want to do all these steps, right? You want to just, page me. I need the database person, right? And then the platform should figure out who the database person is, and if the primary doesn't respond, the secondary will be mobilized automatically. So these are things that any modern incident response platform offers out of the box, right? And that's something I think for many organizations is more or less the standard mode of operation, right? You have an incident response platform that helps you with coordination, orchestrating incidents. And if you want to talk about AI, how AI can help, we're building an AI SRE, and we think an AI SRE it's hard to say when, right? But my prediction is by the end of this year, it will reach the same level of maturity that we experience with coding agents. Yeah. So we're heading to a future where you won't be paged anymore. You will only be paged if your agent is not able to fix the problem for you.
Yeah, exactly.
Right? And that's what we're building. Yeah. And of course, there's a path to get there, and that path is rooted in you want to get the trust by the humans that are eventually accountable for the incidents that you need to fix, and therefore a very easy first step is by the time you open up your laptop, like you are paged in the middle of the night, you open up your laptop, but you don't look at the raw alert, you look at a full, complete root cause analysis. So that's an agent that when there is an alert, it did the triage. So it recognized, okay, there are 50 alerts. Maybe these are 2 different clusters. And then it does a root cause investigation on the first cluster and the second cluster. And by the time, for us, something we're trying to achieve is have an RCA ready within 3-4 minutes, because when you get paged in the middle of the night, it takes you maybe a minute to get the notification, like 30 seconds, and then until you're ready to look at the incidents, 2 minutes. So it should be, the RCA should be ready between 2-3 minutes. Then you see just an assessment of an ACI, of an agent that did a root cause analysis for you. And what does it do? There is really no recipe for root cause analysis, but there are things that you reason about as a human when you have an incident. Is okay. Questions like, okay, where is the problem located? Like, what has changed, right? That's a question you often ask, because number one reason for incidents are changes, are deployments, configuration changes, new releases, new features. So that's something that an AI can perfectly do. So it can check the logs, it can check the metrics, it can check recent releases, and then create a whole picture for you. And I think that's immensely helpful.
I think this is going to be, I've been waking up a lot of nights, right? And you sit in your laptop in the dark and trying to fix things, right? And what do you do, right? You try to go into logs and figure out what you change. And as I said as well, did anybody looking in Slack messages, but this is fine, right? I mean, the agent is really good at finding these things, like looking in logs, looking in changes. Yes. Right? So I mean, you don't have to do that. When I get the alert, right, you can also do the background check at once, right? So when I open the alert, it's already filled with all this information. I see it's a big step helping.
Absolutely.
Yeah, so that's kind of like the base analysis. But you mentioned something interesting that we want to get to the maturity when you want to be waken up when agent cannot fix it.
Yeah.
Yes.
And here we are doing analysis, but where do you think it's the threshold that, okay, when we should tell agent should stop trying to fix it?
Yeah. So the That's a very good question. I think the analysis is the first part. Is the part where you you gain trust into the system, and you can just observe, because when you have an agent that is observe only, it cannot do much damage, right? Because what it does is it has read-only access to like we wouldn't recommend to maybe to start with write access immediately. But if it has only read-only access, like even if there is some some crazy vulnerability that's where the agent just goes south and ignores your instructions, there's so much damage it can do, right? Because it has only read-only access to your logging system, to your GitHub repository, maybe to your Kubernetes cluster. And then at one point, you can increase the level of autonomy for the agent, because the usefulness of an agent increases with its level of autonomy. It's just like self-driving cars. If I have a car that can perfectly drive itself, but I always have to pay attention, yes, it's useful. It helps me, but it would be more useful if I wouldn't have to pay attention, right? And that same analogy can be applied to AI SRE agents as well. And there is a path to full autonomy where you start with read-only, and then you go as far as the agent proposes actions that you have to confirm. Yeah, like if the agent needs to do anything beyond a read operation, it proposes that to you, and you can just confirm and have the agents maybe increase the memory on that part, have the agent do a rollback. And then the next level could be there for certain class of actions, there is a pre-approved, certain class of actions are pre-approved. So the agent can execute, let's say, operations such as, doubling the size, the memory size, right? Or increasing CPU capacity, or like probably not a rollback. A rollback can be risky. But yeah, there are class of operations that you can pre-approve, and the agent can execute those autonomously. And then at one point you want to have like more autonomy, and the agent would only page you for very novel incidents, right? When something that is the agent hasn't seen before is risky. I don't have the answer yet how this level of autonomy can be done in a very safe manner. Like I wouldn't do it today, right? Even though I believe it is possible, I wouldn't do it because there are still risks, and we're certainly working on that as well. But we're starting with the basics.
Yeah, but isn't it like growing its confidence, right? You start with seeing, and then it gives you like, hey, I will do this, right? And you can look at it like, yeah, that sounds good. You have to do it today, like you sit and press enter, right? Yeah, it looks good. Up, that's wrong, right? The same approach would probably be doing, like, but you were sitting in your underwear at 3 o'clock in the night, pressing enter.
Yeah, I think we also have, the same principle a bit with the people. Like when you get someone new somewhere, you give them a bit. When you see that works for them, that they okay with it, then you give them a bit more responsibility and so on. So I think we can, limited trust roll a bit to both as to humans
and I agree
to the machines as well.
This is a perfect example where we can get help from AI in security, right? In the internet, getting help with the change is one thing, by getting help with all that information you need during the internet to make your decision, right? You need a lot of information. It's a lot of logs. Even if you have it collected in one place, you need to go in and search them and like filter. We've all been doing that stuff, right? It's so much easier to just chunk it over and like, you know what? I'm looking for this pattern. What do you see, right? So I think it's going to be. And
you also usually need to check a lot of different hypotheses as well. So at least you can get the agent to go for the basic ones. The most common cases, as Birol mentioned. You have the CPU, memory, rollback, and so on. Maybe for now it's only the research, but maybe the next stage is to allow agent to do this stuff autonomously, or try it out on the daily during the day. And let it, once it's checked, let's try to roll it autonomously at some point as well. And only more complex edge cases you leave for the humans, for example.
Yeah.
or between humans and agents. Yeah,
I see it also. I mean, if you look at like web logs, you get like 401. Someone try to log in with the error, right? A regular web app will have them a lot of times, right? So you won't get alerts, right? And then you have some thresholds. Maybe if you get 500, you get alerts, right? But if someone makes like 200 and then wait 5 minutes and 200 again, you won't get an alert, right? You need to have a trend on these things, right? But if you chunk it into an LLM, it's like, hey, what's going on the last 24 hours? It will find those patterns and, hey, you know what, this IP actually made this many 401s, right? This is something you need to look at. So you can see other patterns that not regular trend-based solutions they can probably pick it up, but much harder for them to pick up, right? And it's yeah.
I think it's a mix also, depending to what it has access. Recently, I had at one customer we had a change, and in code everything looked perfect, and we couldn't figure out what's wrong. Turned out that it didn't deploy because certain thresholds were below, so it didn't see these files anymore because the PR was so big that it didn't trigger certain parts because it only was analyzing up to few hundreds files changed, and above was not. So it didn't trigger part of the deployment. So part of got deployed and part was not deployed, and that's why we got clash and we couldn't figure it out. An agent couldn't figure it out either. He was looking for more issues in the code.
Yeah.
Yeah.
That's funny.
That's a tricky situation.
Yeah. But it's going to be solved, right? More lines go. Okay, but the last part of the incident is always the reporting, right? And it's always the one I think sometimes that you kind of drags a little bit to do, right? You're so happy things are working right. It was the middle of the night, you just closed the lid and you went to sleep, and then you go back into the office like, oh, I need to write the incident report or like communicate to clients and all that. But today, it has never been so easy to write these reports, right?
Yes.
It's just like, here's the Slack thread, Gabunka, here is my template, go and do it, right? So it doesn't really feel that there are any excuses today to not write this stuff, or what do you say?
Yeah, I think that's an area that's also one of the very early use cases we developed, like post-mortem generation, writing the incident report. And to me, it's irresponsible not to get the help of an LLM for those tasks, because when you have when you have an impactful incident where you had maybe 20, 30, 40, 50 people in a war room channel.
Yeah.
There's a lot of text going back and forth, a lot of decisions being made, a lot of very useful information that should make it into the report, right?
Yeah.
And what we do is we combine the machine generated data, which means everything that was logged properly, where maybe there was an alert, then you received 50 more events, then it took you 3 minutes to get the first responder taking care of the alert, and then you created an incident, and you have an entire timeline around that. So there are events that are where you have a proper format, and there are more or less automatically logged on the side. And if you combine those two sources, all the machine generated events with whatever was discussed during in the war room, or maybe even you have a war room meeting, right, where you have many people talking to each other. These things, it's irresponsible not to leverage an AI for that, because it makes preparing for the post-mortem, it doesn't replace the post-mortem meeting. It makes preparing for the post-mortem meeting much easier, because with AI, you can have an 80% version of that post-mortem document that is a reconstruction of the incident, of, timeline, business impact, what actions were taken during the incident, and then in the post-mortem meeting, you can then actually focus on the valuable part, which is, what we talked about in the beginning, taking this as an opportunity for learning, for architecting more resilience into my platform. I think that's a no-brainer to use.
Yeah, and I see it here is coming back as well, as I said before, like have an AI to help you, like mitigate the incident. Like, here is something also you can use it, like it makes the post-mortem, but also create like, I would like to make these changes, right? I would like us to increase the timeout on the load balancer. I would like us to increase this. It can maybe even go into an example, like, okay, and we need to update the code base and adding these changes here, like to really getting that learning circle back to the left part of the stack.
To prevent the next incidents. And also one thing which we are not generally mentioned, developers usually hate writing reports in the documentation.
Yes.
So that's one of the first use cases when people actually started using AI, and you get more trust, because like, oh, I don't need to write this text. Yeah, sure, great. Or it's also, the another big problem there is keeping the documentation updated in general. So if it's incidents, because the code is also changing much more dynamically now because of the AI. So documentation and risks coming with it also are not as well documented as. And let's be honest, that was a problem even before AI so widely split. I remember courses from Azure when they had, they were teaching on the outdated documentation because they were releasing features so fast a few years back. I think if we can make it also to, work for us for stuff which we don't want to work with, why not?
But that's really the thing, right? You need to have this AI agent like in the circle, right? To read your repos, to know about the documentation that you have, like giving it access to the alert, so you can make sure that your alert is in good place, right? And it can help with that as well. But then it's ready to help you really when you get the incident, as you said, like help you with the like incident when it occurs, right? To make with logs and maybe even help you to resolve the incident, but also in the end, like to like this happened. This is how we can fix it for it to never happen again, right? So, yeah.
It can even, go as far as, for example, like depending on, again, how much capabilities you want to give the AI, we integrate with your like source code management tool. It can even, go as far as they suggest, architectural changes, and then if you have a document that, that is useful, has, first of all, it's like just the reconstruction of the incident. I think that's useful on its own, but then the agent can go beyond and suggest measures for how to mitigate that incident. That to me is a solid basis for a fruitful post-mortem meeting. So you can have a discussion and not spend, if you want to do a really good post-mortem meeting, if you do it manually, it really takes time. Like if you just go to a post-mortem meeting without preparation, then it's just a meeting that was, it's wasted time, right? But if you go to a meeting prepared and you have the full post-mortem document prepared, then it saves you, hours of preparation, and that's why it's irresponsible not to use it.
It is. We're coming up on 45 minutes, so I think, and we kind of ended my points here. But do you want to have any last words here before I press stop here?
I mean, the last words would be, those are probably not necessary anymore, because we do observe an appetite to leverage agents also for production. But so people are, especially the ones that are very senior and they're really good in their profession, they are more the opposite of optimistic, like more like a little bit more careful, let's say, more careful in adopting agents in production. And my advice would be, just give it a try. Start with a risk-free approach, right? Start with the basic tasks where an agent cannot do much harm. And yes, there is chatter about, okay, if I use agents too much, will I lose the capability to fix incidents? This problem applies to many disciplines. It applies to same as to coding. It's always good to have a good understanding of at least one abstraction layer below, right? So if you let's say you were a software engineer before AI, it was good to understand, even though maybe you don't have to manage memory manually. It's good always to understand, okay, I don't have infinite memory. I need to. I know there is something like garbage collection. And it's same applies for agents. So we're the last generation of engineers who, knows how to code by hand and have hopefully written a significant piece code by hand. But now we need to adopt agents, right, for software development, but also for operations. And it's not a nice to have. It's not a nice to have because it's becoming the new standard that lets you be faster, right? And being fast is something that is it's an attribute that you want to have, right? Your organizations, if you are able to reduce cycle times, if you are able to if you are relatively faster than your peers, then it matters to your customers. Yeah. That's why I think adopting agents is not a nice to have. It's something that we should all do, and it will also apply for production, for operations.
Yeah. Paulina, anything?
I think the only one good thing is that with security and with agents in the security, it comes a bit like security has to be everywhere in whole process on every step, and putting AI into it, it's very similar in my opinion.
Yeah, but I think this is a perfect fit for where you to start using AI today. Like if you don't have these capabilities in your process today, you should start looking at it, right? Why don't you have it today, right? It's not like it's super secret or hard or anything, right?
Yes.
If you don't have an agent or like backup support by some LLM or something, when you do like incident, even from writing reports, you're doing something wrong. You should start looking at it at once, right?
Security is actually a very good example, because imagine, and this is how why being fast matters, right? So imagine with agents, you are capable of detecting vulnerabilities a lot faster, right? So, and if you think, okay, I'm not going to trust an agent to detect my vulnerabilities in my software stack, but then an attacker will use agents to detect vulnerabilities in your software. So if you don't use agents to detect the vulnerabilities before a potential attacker detects them, so that's why it's not a nice to have, right? Because it's not something, like you said, it's not something that is only it's a secret. It's like the new mode of operation. So that's why we should embrace it.
Yeah, start using it today. Okay, and with that, I will press stop. Thanks for tuning in.
Thank you for having me.
You have been listened to DevSecOps Talks with Mattias, Andre, and Paulina. For notes and information, please visit devsecops.fm. Thanks for tuning in.